Hello, we have another maths video. Well done to everyone uploading their work. Brilliant job. Well done to everyone doing it. Even if you don't get a chance to upload, that's brilliant. We are working on pictograms and line graphs this week. Today, pictograms. Now I know that's something that we learn in year 2 and year 3 as well. So just stop for a minute and say, what is a pictogram? A pictogram. Do you remember? What is a pictogram? Well, a pictogram is a way to show, what does this say? Numerical data. And data means information. And numerical means number information. So information in the form of numbers. That could be amounts of people, could be measurements, how big or how long. And pictograms use pictures. That's why they're called pictograms. And in a pictogram, each picture counts for a certain amount of things. So it's a way to show the data really clearly and simply, a way to communicate information. So let's have a look at this one. First question, can you see at the bottom it says, what is this pictogram about? What is this pictogram about? Well, when we get any kind of graph, bar graph, line graph, pictogram, we should always look at the title first, before we start looking at the numbers or anything else. So let's look at the title. Where's the title? Well, here it is. It's at the top. Every graph, pictogram, whatever it is, should have a title. The title is Favourite Food of Children in Year 5. Okay, so it's about the food what the children in Year 5 like most for their food. Okay, once we've looked at the title, then we need to start looking at some of these headings across what is called the x-axis. We can remember that. This x-axis is this line going along the bottom. The x-axis goes across, and I remember it because x, the letter x, is across. Okay, so we've got pizza, lasagna, salad, fish and chips, sausages, beans on toast. Okay, so what is this pictogram about? We use the title. That's the first thing we should always look at, the title. Then we need to look at the key. What is the key? Well, it doesn't mean the key for the door. Every pictogram will have a key. It might be here, or sometimes it will be underneath. Here, the key tells us how many to count for each of the symbols. So, look, for pizza, there's 1, 2, 3, 4 smiley faces. You might think that means, 4 smiley faces means 4 children said pizza was their favourite food. That's not right, because we've got to look at the key. 1 smiley face counts for 2 children. If we don't look at the key, we'll get the wrong idea. So what does each smiley face count for? Well, each smiley face counts for 2 children. So let's now look and think. We've got to use this information. Okay. We can now start to do what is called read the pictogram, because, do you remember, we looked at the title and we looked at the key. So now we can start to read the pictogram, means we can start to understand it and get the information out of it. Question up here, how many children said pizza was their favourite? I wonder if pizza's your favourite. It is a very popular food. How many children said pizza was their favourite? Well, 1, 2, 3, 4 smiley faces. Does it mean for children? No, it does not. Each one counts for 2. So actually here, if we were counting up, we've got to count in twos. We've got to count 2, 4, 6, 8. Really, we should say each smiley face counts 2, 2, 2, 2, 2. We should use multiplication here, shouldn't we? How many children said pizza was their favourite? 4 smiley faces. Each one counts for 2. It's 4 lots of 2. Look, 1, 2, 3, 4 twos. 4 times 2, 8. How many children said pizza was their favourite? 8 children. What about how many? Next question. How many children said fish and chips? Oh, let's find fish and chips along the bottom. Okay, here's fish and chips. Well, 1, 2, 3. Oh, 3. But this is not here, not a full face. It's half a face. Now, the key tells us that 1 whole smiley face means 2 children. And the rule for pictograms is on the bottom here. Half of the picture means half of the number on the key. Okay, so we would count it 2, 2, 2. Then this is half of 2. Half of 2 is 1. Okay, so we'd actually say 3 times 2 equals 6. Add on the 1. The 1, which is the half a face, 6 add 1. How many children said fish and chips? 7 children. Oh, it's a bit messy, my work today. Sorry, children. 7 children said fish and chips. Okay. How many children said, oh, now this is interesting, either sausages or lasagna? Well, let me find that information out. Sausages is this group of children, isn't it? Well, 1, 2, 3. 3 times 2 is 6. How about how many said lasagna? Well, lasagna is over here. 1, 2. So it's 2 times 2 equals 4. So, how many children said either sausages or lasagna? It means you can count anyone who said lasagna and anyone who said sausages. So, we could say 6 that like sausages, add 4 who said their favourite was lasagna, is 10. We could have just done a multiplication though, couldn't we? We could have just done 1, 2, 3, 4, 5. We could have done 5 times 2, 10. How many children said either sausages or lasagna? 10 children. We could have just not done this amount plus this amount. We could have just thought each of the symbols is still worth 10. There are 5 symbols, so it's, sorry, each of the symbols is worth 2. There are 5 symbols, so it's 5 times 2. Okay, so for this kind of question, either this or this, you can actually count all of them in both categories. How many more children said pizza than lasagna? Well, here's the number that said pizza. Here's the pizza. Here's the lasagna. Well, how many more? Well, the 1 here and 1 here, that's the same. This is the same, this is the same. But where do the ones that are more start? Well, look. They start here, don't they? Because if it was just these 4, 2 for pizza and 2 for lasagna, then it would be none were more because it would be the same amount. Not more, not less, but the same. So the pizza, these two are the smiley faces that are more. So remember, each one counts to 2. So how many more children said pizza than lasagna? We'd say 2 times 2 equals 4. 4 children. Could we have worked it out a different way? Yes. Yes, we could have done. We could have said pizza was 8 children altogether. Lasagna was 4 children altogether. We could have found the difference. We could have said 8 take away 4 is 4 children. But here we could have perhaps just counted the ones that were more and multiplied. Maybe that was even easier. This is what we call finding the difference, comparing. How many fewer children? Now, what is that word? How many fewer children said salad than lasagna? Fewer is a word that means less or smaller. How many fewer children means how many less children. How many fewer children said salad than lasagna? Well, here's the lasagna. That's 4. Here's the salad. That's 2. Well, what's the difference between those two? Well, up to here, 1 and 1, that's the same. These are the ones that are more, and it's the same ones that are less on the other side. Because if we had another smiley face, it would be the same again, wouldn't it? So, how many fewer children said salad than lasagna? Well, we could do 4 lasagna, people who said lasagna was their favourite, take away 2 who said salad, and our answer will be 2. 2 children. Or we could have done just like before, we could have said, well, the difference between these is this one here. That's the one that is less, so it's 2. Okay, which food was twice as popular as lasagna? What does that word twice mean? Do you know? Twice is another word for 2 times. 2 times as popular as lasagna. Right, let's find lasagna. So lasagna is 1, 2 smiley faces. So 2 smiley faces for lasagna. Twice as popular would mean not 2 smiley faces, but 2 times 2. 4. Here we have it. Look, there's 4 here. 1, 2, 3, 4. We can see the number of symbols for pizza is 4 compared to the number of symbols for lasagna is 2. We could think of it another way. 8 people like a pizza as their favourite. 4 like lasagna. And 2 times 4 is 8. Double 4 is 8. So which food was twice as popular as lasagna? Our answer is pizza. We looked for another category, another thing that was 2 times the number for lasagna. How many children overall have given an answer? So how many children in total would be another way to ask that question. In total or all together? How many children overall have given an answer? Oh, we could do this quite a few ways. We could say there's 4 times 2 is 8 pizza. We could say there's 4 children for lasagna, 2 for salad, 6, 7 fish and chips, 2, 4, 6 sausages, and 1 for beans on toast. And then we'd add them all together. We'd say 8 for pizza, add 4 for lasagna, add 2 for salad, add 7, add 6, add 1 for beans on toast. Can you think of an easier way to do that? I can. Remember, we can use that multiplication. We just need to count how many smiley faces there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 whole smiley faces. Then we've got a half here and a half here, which I'm going to count that as 1 more whole smiley face. So not 13 smiley faces, but 14 smiley faces. 14 times 2 equals... there were 28 children. If you see how we use multiplication, because each symbol has the same value. I wonder if we add it up, will we get the same number? I hope so. 8 add 4 is 12. 12 add 2 is 14. 14 add 7 is 21. 6 add 7 is 7. 21 add 7 is 28. Well, wasn't it easier actually to just count up the number of symbols and then multiply it by the number in the key? That was better, wasn't it? Okay. Now, here's a question. Does this pictogram show that pizza is the best supper to give children? What do you think? Now, we must be careful with all of our graphs and pictograms. We can't answer that question from this information. Does the pictogram show that pizza is the best supper to give children? We don't know. This diagram does not tell us that information. And to some extent, that's an opinion as well, isn't it? This pictogram only tells us what children say is their favourite. But that's not the same thing as the best supper to give to children. The best supper to give to children is, we might need to think about other things as well, like how healthy food is and what children ate before, and is it a birthday or is it a special time, and how much money things cost. So there are many decisions, many factors that would be the best supper. We don't know. In fact, I would say this pictogram does not show that pizza is the best supper to give children. It just shows, let's look back at the title, it shows what the favourite food of children in Year 5 is. Maybe it tells us what children would like the most. So, I'll just quickly show you that pictograms can also go not vertically but horizontally. So here, for J.K. Rowling, we're counting across, horizontally, meaning going straight across. I've given you 2 pictograms to answer questions on your work. One about the favourite sports of children in Year 3, and another one about favourite authors of children in Oak class. And I hope that you enjoy this. Looking forward to seeing your work, everyone. Keep working hard. Bye.